What we're going to talk about today is this El Cheapo 3-jaw chuck made in China. 100mm diameter, cast iron body, and of course made in China completely. Costs $69 retail, so really cheap. And let's see if this is anything good. I bought this on purpose for my rotary table. I don't need a high precision chuck on my rotary table because I can slide the chuck on the rotary table to get it centered anyway. So El Cheapo is good enough. But let's see what we have with this thing. It comes with a bag of crap, some screws. Should be, let's see. Yeah, it says 8.8 grade, but I think they are cheese grade. High quality Allen wrench. The external jaws. We will take a look at those later. And, oh, I like these. I really like these. One of those OSHA safety blah 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 compatible chuck wrenches with the stupid spring that drives you crazy after 5 minutes. So yeah, now we can use it. See, you put it in and it doesn't fly out, and you don't die if you leave the key in the chuck for a few seconds. Just don't turn on the machine. Okay, let's take a look at this guy. First thing, let's see if the jaws are hardened. Take a needle file and go to a minor spot. Yeah, and they are hardened. Not super hard, but the file still catches. But yeah, it's hard enough to withstand normal shop environment, at least for a bit of time. Then the reseller I bought this from has his logo sticking out here, and yeah, let's see. And that's crappy, because the logo he glued in there is proud of the surface. So that's stupid. You want to chuck up a disc or use parallels to set up your part up from the back face of the chuck. This interferes with what you want to do. We have an oil spot that's below the surface, that's good. We have this chintzy chuck key with the red condoms on it. Feels, ooh, wow. This feels like there is sand in it. Whoa. Whoa. Okay, this feels really like $69. Let's get the jaws up. Oh wow. Oh man. And we immediately see the reason why it feels like there is sand in it. And the reason is there is sand in it. It seems like when they ground the jaws in place, or they ground them, they left them in place and didn't clean it out after they were done. Because that's there would be no margin left if you do that. Then the chuck wouldn't be $69 anymore. So yeah. Let's take off the back plate, which is held in place with 3 So let's take off the back cover. plate. And there is the second reason why it runs very bad. The pinions and the big bevel gear with the spiral on the other side, they are quite dry. So as you can see, these are the pinions which drive the spiral. When you turn it around, you can see the spiral move. And yeah, now it feels already a bit better as the jaws are out. I think most of the actually feels quite good. Most of the roughness or the crappiness came from the jaws or the dirt in them. So let's take out the pinions. For that purpose there are set screws that go past the axis of the pinion. Yes, these are long set screws, and then you can pull out the pinion to the outside, and as you can see there is a groove cut into them in which the set screw interlocks and holds it in place. And these are also quite dirty, so we're going to wash all these parts down with some WD-40 just to make sure there is no dirt left in them. Let me take a closer look at those components. Now we can push out the spiral ring to the back, or at least we should be able to do it. Okay, let's take a small grift. With a brass pin to knock it out. Here we have the spiral ring with the bevel gear on the other side. Here you can see the chuck housing. These parts have quite a lot of machining through them. They start as a casting, as they are cast iron. Then they machine. All the interior surfaces are machined. They have to machine the 3 bores for the pinions. They have to do a lot of drilling on the back side. And they have to cut the T-slots in front here, so that's quite, that's at least 1 setup in the lathe, 2 setups in the lathe, machine both sides, and then at least 2 setups on a mill, and then a setup with a dividing head to machine the 3 pinions. Or they do it on a CNC with live tooling, where you can you machine all the features like on a lathe, and then the machine spindle locks, and you come in, you drill and tap on the lathe. You have live tooling on the turret, which can drill, mill, and tap. And also you can come in from the side with a straight tool in the turret and machine the pinion bores. Then the machine can give the part to a second chuck on the other side, a counter spindle, catch it, and then you can machine with the live tooling the T-slots. If you want to know more about this, just Google CNC lathe and live tooling. It's quite incredible what these machines can do. And yeah, it's CE, China export. 100mm, maximum 3500 RPM. That's a bit optimistic for a cast iron chuck. I don't think I would run it above 3000 RPM. If you want to go higher, you want a steel body, a hard hardened steel body chuck, otherwise yeah, you don't know what's going to happen. What I can feel when I handle the part, nothing is deburred. The bores for the pinions have a nice burr, a razor burr, really sharp on them. I will break those. The T-slots are sharp, and also the ends here of the T-slots, they are also nice and sharp. The interior corners here, those are chamfered. Also the edge from the blah 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 here. Yeah, we'll take it later to the surface plate and check one or two things. So let's set this to the side. This is the back plate, which yeah, basically doesn't do a lot. It just closes the back of the jaw. Everything is held in by the pinions. The pinions go in there, are secured with the set screws, and then this is just a cover, so yeah, it's covered. Let's take a look at the pinions and the gear ring. Okay, let's take a close look at these pinions. And as you can see on the surfaces, these are cast parts. They are, I'm pretty sure. Oh, in fact, they are hardened. They are not super soft. The file doesn't grab very much. But these are either forged parts or cast parts. But I think these look, for all that matters, like a forged part. That means you heat the part up to red heat and then you swage it into a die. You put it between two dies, or a punch and a die, and you press it into form. Then you take it out. It might even come out with the square. Then you take it and you machine the outer diameter. This is turned on a lathe or ground, and also this this pin on the end, this guiding pin, is also machined. So now we take a look at the pinion or at the ring gear, and this is machined. The gear teeth, you can clearly see that they came in with a wheel cutter like this, or with a hob. I think bevel gear are hobbed. That means that you have a hob or a milling cutter that's turning, and the part is turning below it at the right speed, and then you can cut all the teeth in a very short time. And as it seems, this part is okay. This is soft. This is cast. This is cast iron for all what it looks. As you can see here on the spiral, you have the open grain structure of a cast iron. The graphite looks. You can see the graphite inclusions, but it doesn't look too bad. It has no burrs on it. Up here we have slight burrs, but we will clean this and hone it anyway. This is the spiral, and there is a lot of grinding dirt in it, but this is machined and then it's ground, or a very fine finishing cut on the lathe. But I'm not sure how you grind this spiral. You could do it on a jig grinder, a CNC jig grinder, and just interpolate a helix, but I don't think they do it that way, because that's a very expensive way of grinding something like this. It might be a specialized purpose-built machine that's but the spiral is ground, so they must have some way of grinding this for high production. And the only thing that comes to my mind is a purpose-built machine, because you would have to go in with a very thin mounted grinding point, go in and then grind the helix like this and go all the way, then come back on the other side of the spiral all the way to the inside. Then you grind the ID. This is also ground, and it's some diameter. It's about 40 millimeters. And the surface finish on the bore of this bevel gear is quite good. These are my chowder marks where I check the hardness with the file, but the surface finish in the bore is quite good. The spiral itself looks a bit, it looks good, but they didn't finish the bottom, which doesn't matter, but it would be a nice, it would look nice if they ground the spiral all the way down to the bottom surface, and might even finish the bottom surface. Would be nice, but it's a non-critical surface, so yeah. These are the high quality set screws. These look really like a crab with a slot. Yeah, and also grinding dirt. That's always when you buy machine equipment on a budget, like this chuck for 69 bucks. You will find grinding dust in it, and yeah, clean this mess off camera. I'm just going to brush everything down with WD-40, and we'll be back. Okay, I washed it all out. As you can see, there is quite a lot of residue in the WD-40 I used. That's all the grinding dust I got out there, and you can see that I put it back together, and I used some molybdenum disulfate paste, which I I mixed myself. I took some lithium grease and superfine mollicot powder and mixed it up into a very heavy paste, which will stain every white sofa in your house into a nice glossy black. So be careful with that stuff. The moly is very good for low speed and high pressure situations, like on the rack and on the pinion and the gearing in this chuck. And as you can hear, it's moving nice and free. Now we can put the back cover on. Okay, this feels way better than before. Yeah, now I like it. I can use this. Okay. Okay, what I'm going to check is if the face of the chuck body is parallel to the back side of the jaw, and if the steps on the jaws are parallel to the back face of the chuck. The back face is resting on the surface plate, so we just check the heights with the dial indicator. So let's go down onto the face. 0, and move it across the surface. And this looks pretty good. Oops. Oh, I dropped into the indentation from the stupid sticker here. And it drops slightly to the center, but it's less it's 1/100th of a millimeter, so half a thou. Okay, 0. And it also drops 1/100th of a millimeter to the center. And the third surface also drops to the center 1/100th of a millimeter. But very, very nice all around. So the chuck face is very parallel to the backside. That's good. I'll go for the most outer step. We start 0. Oh yeah, that's okay. That's about. Ooh. Okay, this is not super even. I'm going to average it out. We have -1 here and oh yeah, that's 0 in overall. Okay, this jaw is low about 2/100th of a millimeter, and this one, so yeah, it's about 1.5 of a millimeter low. This is this one is high. This is +300, and this one is wow. +2 +5. That's I don't like this very much. Let's see how much play they have. I try to of course they have play in this direction, as by the spiral in the chuck, but I wanted to know if they can lift. That's let's take a piece of round stock, get our dial indicator on the surface here. Okay. I'm very lightly clamped here. I can move the part still. I'm zeroing out the dial indicator up here. And now when we tighten the chuck down, you can see that the jaw lifted about 1/100 of a millimeter. It buckled up. Let's see what happens on the outside. In theory, it should go down slightly. But I have been wrong before. Yeah, very slightly. About 0.5 of a millimeter. So the jaws sit very tight in the slots. That's good. If the jaws would be very loose in the chuck itself, they would buckle out like this, and you could read it on the dial indicator, because it would rise in front here and drop down back here. But these jaws are actually, is that a word? Actually, quite tight in the slot. And I think what we're going to do is we're going to take this this brand new chuck to a surface grinder and make it even better. Why I'm insisting on these surfaces so much is because when you have it on the milling machine on the rotary table and you chuck up a disc-shaped part, you want the disc-shaped part to run dead true. That's achieved the easiest when you rest the part on these steps of the external, on the reversed jaws. So yeah, that's why we're going to grind it. we will preload the chuck. We'll just take this piece of brass, drop it in, raise it a bit from the table, and just clamp it lightly so the jaws don't go this way when we grind them. You could also grind it on the lathe with a tool post grinder with a cup wheel. You could face the steps down until they run true. Preloading, and we're going to take some masking tape to protect the chuck from grinding dust. Okay, we're over at the surface grinder and I have the chuck stoned down on the back side, and the magnet table also, the magnet chuck also stoned and clean, and now we can set the chuck up on the magnet. We will have one jaw to the back and just eyeballing it square to the fence, and that's the jaw we're going to grind. Then we unlock it from the magnet, turn it, grind the next one, and so on until we have one height done. Lock it. Okay, we want to see if the grinding wheel clears against the jaw on this side, and we have clearance. Very lightly, just judging by the light between the jaw and the grinding wheel. So now we can proceed on. I want to show you this to you. I took a cut of 200ths of a millimeter and we are making contact on the left edge of this step, but not in front here. There's still paint left. So by doing this you can also judge very well how the surface looked before you did your grinding or while you did your grinding. So I think we have to go another 2 or 300ths of a millimeter. Okay, now you can see that all the paint is gone from the surface, so we hit the whole surface with the grinding wheel and we know it's flat. And we took off 0.034 millimeters. Let's zero this so we can go to this setup on the next jaw too. And if you wonder, I have mounted this Mitoyo 1000th of a millimeter digital indicator up here to the surface grinder, and I have a rod down here, and I have a bracket on my wheel head down here with an ejector pin, which acts as a support piece where the indicator can measure against, and this is adjustable in height with this locking handle here. Okay, we ground the first surface. Now we can unlock the magnet, turn it, and go up against the fence again, lock it. Now we raise our wheel head to 0.10 millimeter Okay, brought the wheel in as before. Now we will plunge down again and do the same thing. And move it to the next jaw. There we go. Raise the wheel head and then we come down. Okay, now you can see that we ground all three of the stepped surfaces. This one has a very slight low spot in the corner, but the others cleaned up very nicely. And I'm not going to grind again because the majority of the surface is flat. Now we go to the surface plate and check it. Okay, let's bring the dowel indicator down. This reads 1/100 of a millimeter, by the way, so half a thou per indication. I shouldn't do inch conversations. We have 0 across the whole surface here, and we have pretty much 0 over the whole surface on this jaw too, and this is the last one, and it's 0 too. So, surprise, the surface grinder can make parts accurate. And yeah, next I will grind the 3 lowest spots or steps. Then I will change up the jaws and do the same on these. Okay, I'm just adding the engraving for the jaw number to the chuck body. Already did number 1, and I'm just indexing by eye. No need for a dividing head here. There we go. 1, 2, and 3. And I also picked out the stupid sticker from the reseller. And I Scotch-Brighted off the ugly laser engraving of the maximum RPM and the Chinese export sign. So now it looks a bit more serious. Okay, I think that's almost good enough. We have the jaws all ground to be parallel to the back face of the chuck, and they are all the same height on all steps, inside and outside jaws. And we did some cosmetic work and we cleaned it, and it's running smooth. And we took a look into the internals of a scroll chuck, so I think that's good enough for one video. Thank you all for watching and see you next time.